Yes, welcome back here to Year 7 Maths, and this is the second lesson that I'm presenting to you this week in week 3, and it's a lesson on, as you can see on the screen, solving problems with equations. So if you have your notes, you should have or if you've got a copy of the class notes, you should have that title already at the top of the notes. If you're using your book, please write down that as the heading, and please also write down the date that you should be accessing it, which is Friday the 8th of May. Now the learning intent for today, it's on the next slide, there it is. We are going to revise how to solve equations. We're also going to revise how to write an equation, just briefly. Then we're going to put that together in order to solve a real life type problem. The success criteria, how we're going to get there is, as I said, revise how to solve equations. So looking at the two methods we did in the live lesson on Wednesday, backtracking and the balance method. And then we'll look at a couple of real life problems to solve. Please ensure that you write down the learning intent in your book. If you have the notes, you already have these. And at any stage during this presentation or during this video, you can pause as you need if you need to write something down. All right, so let's start with a review of writing equations. So we've got a little bit of a scenario here. Albert is A years old, and this is 10 years less than 4 times what Bob's age is. Now, Bob is B years old. The question is, can you write an equation to represent this scenario? I'd like you to pause the video for about 30 seconds and see if you can go about writing an equation. How'd you go? If you are still with us and you're a little bit stuck, not sure how to write the equation, or you have written an equation, the first thing that you should have done is to find your variables. Now, I know that that's already been given in the question, but A will be Albert's age and B will be Bob's age. Now, again, if you haven't written down an equation, the last step is basically to interpret this sentence here that I'm underlining and come up with an equation for that. Remember, an equation is going to have two sides to it, a left-hand side and a right-hand side, and an equal sign in the middle. Pause the video again for 30 seconds if you'd like another go at writing the equation. Okay, how'd we go? Now it says Albert's age is A years old, so I'm going to start with A for Albert. And that's the first part of my equation. And that's going to equal something to do with Bob's age. Now it says in here, if I jump to the second part of the sentence, it says 4 times Bob's age. And Albert's age is 10 less than that. So 10 less means subtract 10. So I should have an equation that looks a little bit like that. A equals 4b minus 10. Or, using correct mathematical convention, 4b take away 10 like that. Get rid of the multiplication sign. How'd we go? If you didn't quite get it right, please take the time now to write it down properly. The other thing I want to talk about quickly is solving equations. Now on Wednesday in our live lesson, we talked about how to solve equations to isolate the variable. So that means you get the variable by itself. So eventually when you work some of these questions out, for example, in number 1, you're going to have x equals and whatever the number might be. I don't know, it might be 2, something like that. We looked at 3 methods in order to do this. And the first method was called inspection. Now, I'm going to suggest to you that in this lesson, for these questions, you probably won't be able to see the answer straight up. You might be able to, but what I would actually encourage you to do is to pick one of these 2 methods. I'd like you to pick either backtracking or I'd like you to pick the balance method. So remember, backtracking was when we looked at how we formed the equation to get the solution, which was 16, and then what we did to undo that equation. And to undo the equation, we looked at inverse or opposite operations. Similar idea for the balance method, except the balance method actually asked us to keep our equation, both the left-hand side and the right-hand side, in balance by doing the same thing to both sides. And again, the same thing as the opposite or inverse operations. So for instance, if you wanted to do the opposite of plus 1, you would take away 1. And you'd take away 1 from both sides. That would keep your equation in balance. Now what I'd like you to do is I'd like you to pick one, or maybe try both of those methods if you wish. But I'd like you to try and solve these three equations that you see on the screen. And I'm going to go through a method of backtracking, the method of balance or balancing for one or both or two of these equations that you see here. So pause the video for about 5 minutes and see if you can get the solutions out yourself. Okay, how'd we go? Hopefully we've got three answers there, and hopefully we've checked our answers. Now, I'm going to show you the method of backtracking to solve number one. All right, and as I suggested to you, drawing these two little arrows in, backtracking looks at how you have, I guess, formed this equation. So we start with the letter, which is x, okay, and I've got 2 times x here, so that means I've multiplied x by 2, and then I've added 4, and that has actually given me the solution 16. Now, over here on the other arrow, I now undo all of these operations by doing the opposite or inverse operation. So if I start with a 16, now working backwards, I do the opposite of plus 4, which is to take away 4. And just in my head, I do 16 take away 4, and I end up with 12. So I'm just going to think of that as well. I then do the opposite of multiplying by 2, which is to divide by 2. Now, to get the final answer, I then get that 12 that I've just been thinking about, and I divide that by 2. And you know that 12 divided by 2 is equal to 6. So I think the answer for the first one is x equals 6. But I'm not 100% sure, so I'm actually going to check my solution. Now, how do I check my solution? I think about something we did last Friday together, which was called substitution. Now, substitution means I'm actually going to replace the x right there in the original equation with my possible answer, x equals 6, and I'm going to check whether I end up with a true number sentence or not. So let's check. I'm now going to go 2 times 6, because x I think is equal to 6, plus 4. So 2 times 6 equals 12, and 12 plus 4 equals 16. So I've got a true number sentence, because I should get 16, and I ended up with 16. And so that means my solution, x equals 6, is indeed correct, and I'm happy. And hopefully you got the same for number one. If you did the balancing method and you got x equals 6, excellent work. Hopefully you also checked your answer by substitution. Actually, let's take a look at this balancing method. And as I said, the balancing method is we're doing the same operation to both sides to keep it, or to keep the equation in balance. Now I'm going to work on number 2 here. And to solve number 2, the first thing that I'm going to do is I'm actually going to take away 1 from both sides. Now, why am I going to take away 1 from both sides? It's going to get rid of that plus 1. And you might be thinking, well, why do I do that? It's because it's the first step in trying to get the variable or that letter all by itself. So now I've taken away 1 from the left. I now need to take away 1 from the right, because I need to keep this equation in balance. 3y plus 1, take away 1, just leaves me with 3y. And 13 take away 1 gives me 12. Now what I didn't say was that that 3y actually means 3 times y. And so now to get rid of that times 3, I need to do the opposite of multiplying by 3, which you should know is dividing by 3. So now to keep the equation in balance again, I need to divide both sides by 3. This will leave me with y all by itself. And over here on the right hand side, I've got 12 divided by 3, and the answer is 4. Well, I should say the answer could be 4, because now I need to go and check, and again I check by substitution. And up in the original equation here, I replace that y with 4. So I go 3 times 4 plus 1. 3 times 4 is 12. 12 plus 1 equals 13. I've got a true number sentence, and therefore I've got my solution correct. So that's the balance method, doing the same thing to both sides, the opposite or the inverse operation to both sides. By the way, if you tried question 3 as well, which hopefully you did, pick one of those two methods, you should actually find that B is going to equal 5. Okay, so the answers were 6, 4, and 5. And hopefully you got all of those right. If you didn't, please take the time and go back, have a look at the last couple of slides and make sure that you write the answers down properly. And then actually try number 3 yourself, because you notice I haven't put any working out there, but I have given you the answer. And so your challenge would be to get that answer yourself. Okay, let's have a look at how to solve problems. So right now in your book, I'd like you to put this as your heading, solving problems with equations. And underneath, I'd like you to write down those dot points there. Now those dot points, you don't necessarily have to write down straight away because I'm about to go through them, but you can pause the video at any stage and you can write them down. Why are we solving equations? It's because equations are actually very useful to solve everyday problems. You now know how to solve an equation. You will now write your own equation like we did at the very start of the lesson, and then you'll be able to solve it. And therefore, you'll be able to solve a real-world problem. The last little dot point here, though, says that there might be more than one method and there might be more than one answer. So you need to think very carefully and work very carefully through these questions. So as I said, pause the video and make sure that you get those 5 dot points down really carefully, please. Okay, next slide. Perhaps even more important than that previous slide was that here is a little bit of a technique on how to solve problems. Okay, and the technique is this. Read the question carefully, highlight or underline the key information, draw a diagram if needed, define the variables and write an equation. That's probably the important one when it comes to algebra. Actually solve the problem and then write a sentence answer. So what I'd like you to do is to write down those 6 steps, right? These 6 steps here. Pay particular attention to number 4 because that's the main starting point is to make sure that you define the variables and write the equation correctly. Because after that, solving the equation we should be pretty happy with. And then the last bit is to write the sentence answer. So just pause the video briefly now and write down those 6 dot points. All right, let's jump straight in and solve a couple of equations. So read this question through with me. It's all about Phil. Phil has 70 cents in his pocket and he's feeling a bit hungry. He goes down to the shop and he buys a pear. After he's bought the pear, he now has 25 cents left in his pocket. Now, if X is going to represent the cost of the pear, also in cents, your task is to write an equation and solve it and actually work out what the cost of the pear is. Now, I'm pretty sure some of the more capable people are already sitting there working out, well, I know what the cost of the pear is. It's pretty easy. But for purposes of demonstration, I'm going to go through these steps to show you how to solve these problems. So I've read the question, and now we're going to highlight the key information. And that's the key information there. The original 70 cents that Phil has in his pocket, the 25 cents that he has left. I also have defined the variable, which is X, and that represents the cost of the pear. And the question that we need to work out is what actually is the cost of the pear. So I've read the question, I've highlighted, I don't need to draw a diagram, and you can see that already I've started to define the variables and write the equation out. So let's jump on to the next slide and let's actually define what the variables are. So it already says in the question, I'm going to let X be the cost of the pear. And underneath that, I'm now going to write my equation. And my equation is going to look a little bit like this. I'm going to start with the cost of the pear, and then I'm going to have what's left in his pocket. It's 25 cents. So 25 cents is left in Phil's pocket. Now you should know that the cost of the pear plus the 25 cents would give you back or get you back to the total that he started with, which was the 70 cents. So that's my equation. Now I'm going to solve that equation. To solve that equation, I'm going to use the balance method because I can see it's pretty easy to keep this equation in balance and getting rid of that plus 25. I get rid of the plus 25 by taking away 25. So I take away 25 from both sides, like so. And that keeps the equation in balance. On the left-hand side, I've just got x, and on the right-hand side, I've got 70 take away 25, which is 45. So I think the answer might be something around 45 cents. Let's check. So I check my solution. I now substitute into my equation 45. So I'm going to go 45 plus 25, and that indeed equals 70. So I reckon I have the right answer. And now I write down what the actual answer is as a sentence. So therefore, the cost of the pair is 45 cents. So what I'd like you to do is, if you've got your book open, I'd like you to write down that that's an example, and I'd like you to write down the example. And then I'd like you to write down all of the working out that you can see on the screen. It might take you a little while, but I think that's really, really important, particularly with the problem solving process. So pause the video and we'll see you on the next slide. All right, here's another example. Now to start with this time, I'd actually like you to pause the video again, and I'd like you to write the example down as you see on the screen. And then I'd like you to go through and highlight the key points yourself. All right, so write the example down right now and highlight what you think are the key points. And we'll check in when you come back after pausing the video. Okay, so hopefully that took you a little while, and you've written down the example, you've read it, and now you've highlighted the key points. Now, just so that we're all clear, the question says, Erica buys 2 cheap movie tickets and one small bucket of popcorn, and the total is $21. If the small popcorn costs $5, how much does one movie ticket actually cost Erica? And I've also put in there that we're going to let T be the cost of the movie ticket, and what we're going to do is write an equation and solve it. And you can see I've also got an important piece of information there, is that we assume that both tickets are the same price. So you would have written that down and hopefully highlighted the key points. There are my key points. 2 tickets, one small bucket of popcorn, totals $21, and the popcorn costs $5, and how much does one movie ticket cost? I could also have highlighted things in this sentence around what the variables are, and I could have also highlighted that, which is to assume that both tickets are the same price, but pretty soon we'll be highlighting the whole thing. Let's go to this problem solving process. So I've still got the example written up the top here, still highlighted, and now we're about to start the actual problem solving process. The first step is to define the variable. And as you can see in the question, I've already suggested that we're going to let T be the movie ticket price. I then see if I can write my equation down. Now, the equation is the tricky bit here. You might like to pause the video and you might like to try and write the equation yourself right now. How'd you go writing the equation? It's reasonably tricky, but let's see if we can follow through the example. Now, it says that she buys 2 movie tickets. So she's got 2 tickets, 2 times T. The word and in here is actually going to represent plus. And she buys a bucket of popcorn, and that popcorn costs $5. So instead of writing down, say, P for popcorn, I actually have a value, and that value is 5. So I'm going to put down 2T plus 5. Now, an equation has an equal sign, and what does 2 movie tickets plus a bucket of popcorn cost in total? Well, it costs right there a total of $21. So that's what my equation looks like. 2T plus 5 equals 21. Check yours, and what I'd like you to do is pause the video again, write that equation down, and what I'd like you to do this time is try and solve it, check that it's right, and then actually write me an answer. Now that might take you about 2 minutes to do, so pause the video now with that equation and see if you can solve it. Okay, how'd we go? Did we manage to get an answer? Again, I'm going to use the balance method, but you could also use backtracking. You could put your arrows off to the side and you could work out your solution using some backtracking, but just for space, I'm actually going just to use the balance method. Now the balance method might be a little bit harder in this case because will I get rid of the times 2 first, or will I get rid of the plus 5? I'm actually going to get rid of that plus 5 first, and so to do the opposite of plus 5, I subtract 5 from both sides. Important we do it from both sides to keep this equation in balance. So I have now only 2t left on the left hand side, and on the right hand side I've got 21 minus 5, and that equals 16. So 2t means 2 times t, so to get rid of that times 2, I now need to divide both sides by 2. And so what you will find is that the price of a ticket could be 16 divided by 2 equals 8. So I may have solved it, and I think I may have that the ticket price equals 8. I'm actually now going to go and check, and I'm going to just check over to the side here using substitution, because what I do is into this equation, I'm now going to replace the t with 8, and let's see if I get that true number sentence again. So 2 times 8 plus 5, let's see if that equals 21. 2 times 8 is 16, 16 plus 5 equals 21. I've got a true number sentence, and so I think my solution of t equals 8 might be correct. So the numbers, or the sentence, the final sentence answer will be the price of a movie ticket is $8. That's it. Job done. That's how you write an equation. That's how you solve the equation. That's how you check it's correct. And last but not least, that's how you write the answer. It's important that you write the sentence answer, because in our world, if you just gave us this, it's pretty meaningless. It's also important to check your answer to make sure that it is correct. And then the most important thing is actually give me a sentence answer that actually answers the question. So folks, that's problem solving. That's writing the equation, solving it, and writing the answer. Please pause the video if there's anything on the slide here that you need to write down. Thoughts? Hopefully you're over here in column A. Time for you to try some. So out of unit 7.5 in your textbook, and if you're at school, hopefully you have access to your textbook, solving problems with equations is the section, and it's on pages 419 to 422. If you're at home, or if you have a copy of the class notes, you will have a copy of the textbook exercises on the class notes. And if you just need a copy of the textbook exercises, they are also available on the eLearn classroom in their own separate section. Otherwise, click through the remainder of this presentation, pause the video, and you'll be able to complete the questions off the screen. Make sure, boys and girls, as I always remind you, make sure that you have submitted a copy of your work to me by the end of today, or at your earliest possible convenience when you've completed these. Now with each of these questions, they are all problem solving questions, and so I'd like you to follow through that problem solving procedure. Write the question, highlight the key points, write the equation, solve it, check it, and then give me a sentence answer. There's question 1 and 2. Now question 1 and 2 are actually quite similar to the two examples that we have in this video. So you might like to use those as a little bit of a guide to help you. Question 5 and 6, it now starts to get a little bit tricky. With question 5, you actually have a multiple choice option here in part A, which is the correct equation. Maybe just to save a little bit of time, we're all about perimeter of a rectangle, and so hopefully you know that the perimeter of a rectangle is adding all the sides together. So you've got a garden that's 13 meters, and you've got the length of a rectangular section is 4 meters, hopefully you'll be using equation D. Solve it and then find the width of the garden bed. Number 6, you're pretty much now on your own, writing your own equation and then solving it. And then over on the next part, question 10 and 11, they're getting a little bit harder. And for extension, question 12, question 13, and question 14. So question 12 is a little bit of reasoning. And then question 13, 14 are open-ended, which means they may have multiple solutions. All right, so if you look at number 14, it's only 2 lines, but there are obviously multiple solutions. Now, I don't expect everybody to be getting up to the extension questions, but I would hope that some people actually have a go at those extension questions. At a bare minimum, I think you should be able to get those first 4 questions done. So questions 1, 2, 5, and 6, all parts. So how did we go today? If we go back to the success criteria, we should be now able to solve equations. We should be able to use backtracking, although we didn't use it that much, but I did show you some backtracking today. We focused more on the balance method, and so hopefully you should be fairly okay with that. Remember, you can pick either of these methods when you're solving equations. And can you solve real life problems using that procedure? So can you write an equation? Can you solve it? Can you check it? And can you write me a solution? I hope so. And I hope that today's lesson has made a fair bit of sense. And I hope that you complete that work, and then after that, have a lovely weekend. And I'll speak to you next week, again on Monday, where we're going to look at something a little bit different, almost at the end of our adventures when it comes to algebra. Next week, we're actually going to look at some graphing. So I'll speak to you on Monday morning, and we'll do some graphing then. Thanks, everyone. Bye.